Okay, hello, my name is Jose Aparicio, and today I'm going to be going over my first set of notes of the AP Pre-Calculus curriculum. And so today's notes are titled Notes 1.1 Changes in Tandem. Basically, these notes are going to be very simple and very straightforward. This is because we're technically not at a later level that we can start to be teaching new stuff. And so right now it's more of a review from your past algebra classes, your past trigonometry classes, and kind of get your motors started back up. And so basically what the first set of notes are going to be about, they're about functions. So a function is a mathematical relation that maps a set of x values and a set of y values such that each input values are mapped exactly at one output values. And you're probably wondering, what are input and output values? Well, input values are also known as your x values, and your output values are also known as your y values. Well, you're probably wondering, how do they look in function notation? Well, let me show you. What is the input value in f of x, and what is the output value of f of x? Well, as mentioned before, our x values are also our input values, and our y values are our output values. Normally, f of x is also known as y, but in this scenario, we're just going to replace f with y and x with x. Let's look at an example. Number 1. W of x is where x is where W is the amount of water in a pool measured in gallons, and x is the length of the pool. Well, you're probably wondering, what is our independent variable? As mentioned, our independent variables are just our x values. But in this case, our independent variables are our x, but they're also equal to the length of the pool in this scenario. But as mentioned, they varied their questions. Now, what is the dependent variable? Well, as mentioned before, our dependent variable are just our y values. But in this case, is the amount of water in the pool, measured in gallons. Next, we're going to be talking about increasing functions. And you're probably wondering, what is an increasing function? Well, maybe throughout your other algebraic classes and your geometric classes, you were introduced to this formula is equal to y equals mx plus b, which is usually the slope. And so following that, you're probably given a graph that looks like this, which this is an example of an increasing function, because as x values increase, our y values also increase. And so later on, throughout this pre-calculus journey, you're going to be given graphs that look like this. You're probably wondering, what is that? Well, you know that these graphs are usually just x, right? Well, this graph is x raised to the third power. You're also familiar with a parabolic function, which are x values just basically squared. And so, what an increasing function is basically just as input values increase, the output values also increase. And so these are examples. These are some graphical examples and some numerical examples. Furthermore, just like increasing functions, decreasing functions are exactly the same. This is because, as mentioned before, y equals mx plus b is the slope of a line. And you could get a negative slope, which would show up like this. Which this is a form of a decreasing function, because as x values increase, the output values decrease, just like shown in this graph. in this graph and in this data plot. Our x values go from 1 to 3, and our y values slowly decline, as shown in the slope graph. Furthermore, we're going to discuss some basic elements of a function. So following the introduction to AP Pre-Calculus or Pre-Calculus in general, you're given a new concept such as concavity. Concavity is basically which way the graph is pointing upwards or downwards. So, in this case, in this graph, in this function, which part is considered concave up? Well, if you think about it, wouldn't this whole part be considered concave up? This is because the graph is pointing upwards, or in other words, it's opening upwards. So that's considered concave up. Now concave down, in this graph we're going to represent it as a red line. So, you're probably wondering, if that was concave up, you're kind of putting 2 and 2 together. So this would be concave up. And you see this you see the lines or the point where the red and the blue intercept right here? That's also known as the point of inflection, where the graph turns from a concave up towards a concave down. All right. Furthermore, our x-intercepts. What are x-intercepts? Well, x-intercepts are wherever the graph passes through or touches the x-intercept. They're also known as zeros. In this case, we have 3. Those are our x-intercepts. Our y-intercepts are, just like our x-intercepts, they're anywhere where our function intercepts or touches the y-axis. In this case, it's right here. So, our last 2 questions. Where is the function increasing and where is the function decreasing? So, based on the graph, we can assume that this part from here onwards, it's increasing. As well as here, it's increasing. Now, from here to here, it's decreasing. So, these are our notes 1.1, changes in tandem. I hope this really helped. I hope this gave you a better understanding on the introduction to AP Pre-Calculus. Don't forget to like and subscribe for more AP Pre-Calculus videos and other tutorials on how to do math. Thank you for watching.